Let us take a look at the Grade 10 2023 November Paper 2. Multiple choice question 1.1. Which of the following is not a property of a metal? So metals are shiny, we know that. So that's out. Ductile and malleable, we know that that is true. Thermal conductors, we know that is true. And that means 1.1 has got to be D. Moving on to question 1.2. An investigation is conducted to study the effect of temperature on the conductivity of a substance. The results are represented in the graph below. So from this graph, we can see that as the temperature is increasing, conductivity increases initially, but then starts to decrease. So which one of the following is the substance being investigated? So copper, aluminium, silicon, or zinc. Now, copper we know is a metal, aluminium is also a metal, silicon is a metalloid, and zinc is a metal. Now we know that one of the properties of metals is that they are good conductors. However, for metalloids, they share some of the properties of metals, meaning that they are good conductors, but they can deviate. So the answer for 1.2 is going to be C because it is a metalloid. Question 1.3. Which one of the following is an example of a chemical change? Separating oil and water using a decanter. You're still going to have oil, you're still going to have water. You haven't created any new substance. So A is out. Condensation of water vapor. If you condense water vapor, you're still going to have water. So B is out. Magnesium burning in air. So burning is a reaction with oxygen. And so then the answer is going to be C. Question 1.4. Consider the balanced chemical equation below. We have 4Al plus 3O2 producing 2Al2O3. The question asks, which one of the following is the correct number of oxygen atoms required to form 4 moles of aluminium oxide? So we're going to do a ratio. They are asking us about oxygen and we have 4 moles of aluminium oxide. So the ratio here for O2 to Al2O3 is 2 to 3. Now they've told us that we have 4 moles of aluminium oxide. So here I'm going to put 4 and here I'm going to put X. Now I can cross multiply. So 2 times X is 2X and that's equal to 3 times 4 is 12. So divide both sides by 2. X is equal to 6 moles of O2. So 4 moles of aluminium oxide will require 6 moles of O2. Now we need to look at the number of oxygen atoms. Now we must remember that in one molecule of O2, remember this is an oxygen atom, or oxygen molecule rather, we have 2 atoms. So to get the total number of atoms, we are going to say 6 moles times, and one molecule has 2 atoms, so 6 times 2 times Avogadro's constant, so 6.02 times 10 to the 23, and that's equal to 6 times 2 is 12, so 12 times 6.02 times 10 to the 23, and that answer is going to be B. Moving on now to question 1.5. Consider the unbalanced chemical equation below. Which one of the sets of coefficients will balance the equation? So here we can simply just do it here. First thing we can do is let's try and balance the nitrogens. So we have 1 nitrogen here, we have 1 nitrogen here. So that's balanced. Next, let's try and move on to, because hydrogen only appears in one place. So here we have 3 hydrogens and here we have 2 hydrogens. So I can get a lowest common multiple of 6. So I can put a 2 in front here and a 3 in front here. Now in doing so, I now have 6 hydrogens and 6 hydrogens on both sides. So that's done. But the 2 has also affected the N. So on this side, I have 2 nitrogens, and so I'm forced to put a 2 here. Now the nitrogens are balanced and the hydrogens are balanced. The last thing now is to balance the oxygens. On the right hand side, I have 3 and 2. I have 5 oxygens. But on the left hand side, I only have 2. Now there's no lowest common multiple for this. So instead, I can multiply by 5 over 2. Now if I multiply by 5 over 2, I'm going to have 5 oxygens on this side, and I'm also going to have 5 oxygens on the right. But I can't have a fraction. So what I can then do is multiply everything out by 2. So I'm going to have 4 NH3 plus 5 O2 producing 4 NO plus 6 H2O. So is that an option? 4, 5, 4, 6. The answer is D. Let's now move on to question number 2. 4 different substances, W, X, Y, and Z, are represented in the table below. Okay, question 2.1 asks, so question 2 and 2.1. Is substance X an element or a compound? Substance X is going to be an element. And the reason for that, it consists of the same type of atom. So same type of atom. You can see that they are all the same. They are those white round circles. Question 2.2, write down the letter of the substance that represents a mixture. A mixture is it's a special type. To identify a mixture, you got to look for different compounds that are there. So Z matches that because we have different compounds. Question 2.3, write down the common name of substance Y. Now substance Y, we need to use the key to answer this. A white circle is a hydrogen. So I have a hydrogen here, a hydrogen here, and a hydrogen here. And the middle one is a nitrogen. So that's N. So I put all of this together, I have NH3. And NH3 is ammonia. Moving on now to question 2.4. Draw the Lewis structure of substance Y. So Lewis diagrams, we need to look at the number of valence electrons. Now nitrogen has 5 valence electrons. It's in group 5. So 1, 2, 3, 4, and 5. There's going to be a lone pair that's not going to react. And then each hydrogen is in group 1, and so it's going to have 1 valence electron. So a hydrogen will attach here, and it's going to have its own electron. I'm going to represent it with a cross. Then a hydrogen here with its 1 electron, then a hydrogen here with its 1 electron. Moving on now to question 2.5. Identify the type of chemical bond between the atoms in substance W. Now, a W is this. Let's try and identify what it is. So W, this is lithium, so Li, Li, and Li, and oxygen, so this is O. So substance W is going to be Li3O, and that's going to be an ionic bond. And the reason why it's an ionic bond is because lithium is a metal and oxygen is a non-metal. So a metal and a non-metal will give you an ionic bond. Question 2.6, hydrogen gas and nitrogen gas reacts to produce substance Y. Write down a balanced chemical equation for the reaction that takes place. So 2.6.1, hydrogen gas is H2, nitrogen gas is N2. So H2 plus N2 produces NH3. Now we need to balance this. I can put a 2 in front here, and I can put a 3 in front there, and that's going to balance it. Question 2.6.2, is this a synthesis or decomposition reaction? This is going to be a synthesis reaction, and give a reason. That's because you have 2 things becoming 1 thing. 2.6.3, so 2 things becoming 1 thing is just an easy way to identify a synthesis reaction. You can say that you have 2 different compounds react to produce 1 compound. You could say that you have small compounds reacting to produce a larger compound. So anything along those lines, as long as it's explained well, will give you the mark. Question 2.6.3, use the balanced chemical equation from 2.6.1 to prove the law of conservation of mass. So I'm going to start with the left-hand side. So my left-hand side, I have 3 times 2, which is 6 hydrogens. So 6 times 1, plus I have 2 nitrogens. So 2 times 14. Nitrogen is 14, correct. And that's going to give me 34 grams per mole. Now the right hand side is going to be 2 times 14 plus 6 times 1, and that's going to equal 34 grams per mole. And so we have proven it. So we can say that the mass of the reactants is equal to the mass of the products. Okay, let's move on now to question number 3. The cooling curve of ethanoic acid is represented in the diagram below. The graphs are not drawn to scale. So 3.1, define the term melting point. Definition for melting point is the temperature at which a solid becomes a liquid. Question 3.2, what is the melting point of ethanoic acid? So the melting point of ethanoic acid is going to be 16 degrees. So 16 degrees Celsius. It is helpful here if you make notes on the diagram. So for example, if this is a cooling curve, then this is going to be a gas state, this is going to be a liquid state, and this is going to be a solid state. So if you are looking for melting point, you are looking for solid to liquid, and that's going to happen right here. So 16 degrees Celsius. Question 3.3. Are the forces between particles stronger in ethanoic acid or in water? Give a reason for the answer. So the answer here is ethanoic acid. It's stronger in ethanoic acid. And the reason for that is because it has a higher melting and boiling point than water. So it has a greater melting point and boiling point than water. Remember, water melts at 0 and boils at 100. This is melting at 16 and boiling at 118. Question 3.4. Write down the phase of ethanoic acid at 5 minutes. So 5 minutes is here. It is going to be a gas. Question 3.5. Write down the name given to the phase change occurring between 10 and 20 minutes. So 10 to 20, it's going from a gas to a liquid. So gas to liquid is known as condensation. Moving on to question 3.6. Explain why the change referred to in question 3.5 is a physical change. So condensation is a physical change because no new compounds were formed. Now question 3.7. At which points A, B, or C are the following statements applicable? So 3.7.1, the forces between the particles are the strongest. So the particles are going to be the strongest at C because C is in a solid state. 3.7.2, the spaces between the particles are the largest. That's going to be at A because they are in a gas state. 3.7.3, the kinetic energy of the particles are constant. That's going to be at B because the kinetic energy is temperature and temperature is constant at B. It's not changing. Okay, now let's move on to question number 4. Some information for the substances iron and the sulfide ion are given in the table below. Okay, question 4.1. Complete the table by providing the answers to questions 4.1.1 to 4.1.4. Do not redraw the table. Okay, so 4.1.1, 4.1.2, 4.1.3, and 4.1.4. So 4.1.1 is asking for the number of protons in iron. So for this, we need to look at our periodic table. iron is here. This is the atomic number. That's going to be the number of protons. It's going to be 26. Let's move on to the next one. 4.1.2, the number of neutrons of iron. So to calculate the number of neutrons, you simply take the mass minus the atomic number. So we'll say 56 minus 26, and that's equal to 30. Let's move on. Question 4.1.3, the sulfide ion. So sulfide ion is sulfur that has either gained or lost electrons. So to figure out whether it gained or lost electrons, we need to look at where it is. So sulfur is here. There's sulfur here. It is in group 6 or group 16. Don't know what's going on here. So this is group 6 or group 16, however you want to count it. Now group 6 or 16, these elements that are in this group will get a charge and become ions, and the charge will be -2. So the sulfide ion is going to be S2-. Moving on now to question 4.1.4, the number of electrons. So sulfur has an atomic number of 16. So the number of electrons would normally be 16. But because this is an ion and it has a 2- charge, it means that it gained 2 electrons. So 16 plus 2, which is 18. Let's move on now to question 4.2. Draw the Aufbau diagram and write down the electron configuration, SP notation, for the sulfide ion. Okay, so we have 18 electrons that we need to enter in. So we'll start with 1s and we make our way up. So 1s, then 2s, then 2p, then 3s, then 3p. Now 1s has 1 block, 2s also 1 block, 2p has 3 blocks, 3s has 1 block, and 3p has 3 blocks. Now remember that the energy increases as you go up. Now remember that the S block can only take 2 electrons, P blocks can take 6. So I have 18 to fill. I start from the 1s and I make my way up. So 1s, there's my 2 electrons. 2s, there's my 2 electrons. 2p, I fill each block first before I pair it. So 1, 2, 3, 4, 5, 6. So in total here, I've accounted for 10 electrons. Then I have 8 more to do. So 3s will take 2 like that. And then 3p, I fill each block first before I pair it. And that's my balance 8. So 10 and 8, 18 electrons. Now the SP notation is going to be as follows. So I'll write it as S2- is going to equal 1s2 because there's 2 electrons in the 1s orbital, then 2s2 because there's 2 electrons in the 2s orbital, 2p6 because there's 6 electrons, 3s2 because there's 2 electrons, and 3p6 because there's 6 electrons. If I add up those exponents, 2, 2, 6, 2, 6, I get 18. Moving on, question 4.3. How many valence electrons does the sulfide ion have? So remember that valence electrons are electrons that are on the outermost shell. So if I draw this, so here's my ion. There's the first shell, here's the second shell, and then here's the third shell. The first shell only has 2, so 1, 2. This entire thing here, that's the second shell. There's 8 there, so 1, 2, 3, 4, 5, 6, 7, 8. And then the 3s and 3p is the third shell. So in total, there's 2, 4, 6, 8. There's 8 electrons there. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 valence electrons. Question 4.4, iron has 3 common isotopes as indicated below. So Fe 54, 56, 57, and they've given us some percentages. So what is an isotope? Isotopes are elements that have the same atomic number or same number of protons, but different mass number, or you could say different number of neutrons. Question 4.4.2, determine the relative atomic mass of iron. First thing we need to do is figure out the percentage here. So the remainder is going to equal 100 minus 91.7 minus 5,8. And that's equal to 2,5%. So this is 2,5. Now to calculate the relative atomic mass, the RAM, it's simple. Just take the mass multiplied by the percentage. So 54 times 5,8 over 100. Then plus the next one is 56 times 91,7 over 100. Then plus the last one is 57 times 2,5 over 100. And that's equal to 55,91 atomic mass units, AMU. Moving on now, question number 5, periodic trends. The table below shows the first and second ionization energy of elements in period 2 of the periodic table. 5.1.1, explain why there is a general increase in the first ionization energy going on from the left to the right across the period. So as you go from left to right, the nuclear charge increases. So nuclear charge increases from left to right. So in other words, the charge of the nucleus, right? Because there's more protons in the nucleus as you go from left to right, so the nuclear charge increases. And then that's going to have an effect on the force of attraction. So because the nuclear charge is going to be stronger, it's going to be higher, the nucleus is going to attract the outer electrons more strongly. And because it's going to be holding on to those electrons more strongly, it's going to be more difficult to remove that electron. So the ionization energy increases. Moving on to question 5.1.2, it is observed that the second ionization energy of lithium is considerably higher than beryllium. Explain this observation. So the question is asking essentially, why is it more difficult to remove an electron here? So this is Li plus and it's lost one electron, as opposed to here. So beryllium, 1, 2, there, my electrons are like this. So they want to know, why is it more difficult to remove this electron compared to removing this electron? Well, it's because of the position of the electron. This electron is much more closer to the nucleus, right? So the electron is closer to the nucleus, right? Further, the nucleus has a stronger pull on it, right? There's going to be a stronger force of attraction between the nucleus and the electron. And because of that, it's going to require a lot more energy to remove the second electron from lithium as opposed to removing the first electron from beryllium. Okay, let's move on. Question 5.1.3, write down the name of the group whose elements have the highest first ionization energy in the period. So that's going to be noble gases, because noble gases are unreactive. And so they're not going to want to give away their electrons or engage in any reactions. Moving on, question 5.2. Write down the chemical formula for sodium oxide. So sodium oxide is going to be Na plus and then O2 minus. Now this is a plus 1 and that's minus 2, so they do not cancel. So I just need to switch these. So I'm going to have Na2O. Question 5.2.2, calcium phosphate. So calcium is Ca2 plus, phosphate is PO4 3 minus. They do not cancel, so I need to switch again. So Ca, and there's going to be a 3 here. Now phosphate is a polyatomic ion, so I should use a bracket. So PO4 and then bring the 2 down, there's the 2. Question 5.2.3, copper 2 carbonate. So copper is Cu, 2 meaning 2 plus, and then carbonate is CO3 2 minus. Now these cancel, so I can simply join them as CuCO3. Question 5.3, write down the chemical name for MgBr2. MgBr2 is ionic, and so we're just going to name it without any prefixes. That's going to be magnesium bromide. Remember, capital M, and the second letter does not have a capital. 5.3.2, this is going to be NH4 that's going to be ammonium. So NH4 is ammonium, and then SO4 is sulfate. Small letter S, sulfate. Now question number 6. Sulfur dioxide reacts with oxygen to form sulfur trioxide as shown in the balanced equation below. So we've got this reaction. In one such reaction, 2450 cm cubed of sulfur trioxide is formed at STP. Question 6.1, state Avogadro's law. So this is 1 mole of any gas at STP will occupy the same volume at the same temperature and pressure. Question 6.2.1, calculate the number of moles of SO3 that formed. So this is at STP, so we can use the formula number of moles equals V divided by Vm. The volume that they've given us is 2450. We cannot use centimeters cubed, we need to convert this. So to convert from 2450 centimeters cubed, all we got to do is divide by 1000. That's going to be 2,45 dm cubed. So this is 2,45 divided by Vm, which is 22,4 at STP, and that's equal to 0,11 moles. Question 6.2.2, calculate the mass of SO2 that reacted. So now that we know the moles of SO3, we can do a mole ratio. So SO2 to SO3 is a 2 to 2 ratio, which is essentially 1 to 1. So if I have 0,11 moles here, I'm going to have 0,11 moles there. Now I can use the formula mass equals number of moles multiplied by molar mass to get the mass. Number of moles of SO2, 0,11. The molar mass of SO2 is 64, and that's going to equal 7,04 grams of SO2. Question 6.2.3, calculate the number of oxygen molecules that reacted. So here I will do a mole ratio again. Now the mole ratio for SO2 to O2, doesn't matter which one we use at this point, is 2 to 1. So if I have 0,11 moles here, I'm going to have half the number of moles for oxygen. So this is going to be 0,055 moles. Now that I know the number of moles, I can use a formula to calculate the molecules. So N, meaning number of molecules, is equal to number of moles multiplied by Na. So 0,055 multiplied by 6,02 times 10 to the 23. And that's equal to 3,31 times 10 to the 22 molecules of O2. Question number 7. The analysis of a compound made up of the elements Na, S, and O provides the following percentage composition by mass. 7.1.1, define empirical formula. So empirical formula is the simplest whole number ratio of elements in a compound. Question 7.1.2, determine the empirical formula of this compound. So I'm going to do this in the form of a table because it's just more neater. So here's my table, like so. The first column is going to be the element. So I'm going to have the element here. The elements that I have are Na, then I have S, and then I have O. The next column I'm going to use for the mass. Now we are going to assume a 100-gram sample. It just makes the masses easier to work out. So if I have 29.11% of sodium in a 100-gram sample, it means I have 21 or 29.11 grams of sodium. Then for sulfur will be 40.51, and then oxygen will be 30.38. Then I can calculate number of moles in the next column. So number of moles, and I'm going to calculate this by saying the mass divided by the molar mass. Now for sodium, the mass is 29.11 divided by the molar mass, which is 23, and that's going to give us 1.27. For sulfur, I'm going to have 40.51 divided by the molar mass, which is 32, and that's going to equal 1.27 as well. Oxygen is going to be 30.38 divided by the molar mass, which is 16, and that's going to be 1.9. Now we need to put this in the simplest ratio. So we can see here that it's a 1.27 to 1.27 to 1.9. Now what we need to do is divide by the smallest number in that ratio. And the smallest number is 1.27. So 1.27 divided by 1.27 is 1. So I'm going to have 1 there. Then 1.27 divided by 1.27 is going to be 1. And then 1.27 divided by, well, this is 1.9 rather. So 1.9 divided by 1.27 is equal to 1.5. Now we have an issue because we can't have 1.5 and we can't round that. So what we need to do is we need to multiply everything throughout. So to get rid of the 0.5, you multiply by 2, then you must multiply this by 2 and that by 2. So you will have 2 here, 2 here, and 3 here. And so then our simplest or our empirical formula is going to be Na2S2O3. Moving on, question 7.2. Determine the percentage composition of water in hydrated copper sulfate. Okay, so first let's work out the total molar mass. So the total molar mass of CuSO4.5H2O is going to equal. So copper has a mass of 63.5, sulfur is 32, plus 4 oxygens, so 4 times 16, plus 5 waters, so 5 times 18. The mass of one water is 18. And that gives us a total of 249.5. Now, if you want to work out the percentage composition of water, so water is this. So there's 5 waters and this is the mass of water. So the percentage of water is going to be 5 times 18 divided by 249.5 multiplied by 100. And that's equal to 36.07%. Moving on to the last question in the paper, question number 8. Calcium carbonate reacts completely with excess phosphoric acid, H3PO4 of concentration 1.25 mole per dm cubed. The reaction is represented by the following balanced equation. The graph below, not drawn to scale, shows the mass of the calcium carbonate as the reaction progresses. 8.1. Determine the number of moles of calcium phosphate formed after 1 minute. So on our y-axis, we have the mass of calcium carbonate. So the mass of calcium carbonate used is going to equal 25, and then after 1 minute we have 10. So that means we've used 15 grams of calcium carbonate. Now we can convert that to moles. So the number of moles is equal to the mass divided by the molar mass. The mass is 15. The molar mass of calcium carbonate is 100, and that is 0.15 moles of calcium carbonate used. Now we can do a mole ratio. So the ratio of calcium carbonate to calcium phosphate is 3 to 1 from the reaction. So if I have 0.15 here, I'm going to call that x. I can cross multiply. So 0.15 times 1 is 0.15, 3 times x is 3x. That means x is equal to 0.05 moles. Moving on. The reaction is thereafter allowed to reach completion. So it means that all of the calcium carbonate was used up. Question 8.2, determine the number of moles of calcium carbonate used. So we'll say that the number of moles is equal to the mass divided by the molar mass. They used 25 grams of calcium carbonate divided by 100, and that's equal to 0.25 moles of calcium carbonate that was used in total. Question 8.3, calculate the volume of phosphoric acid that reacts with the calcium carbonate after 4 minutes. So it means that at the end of the reaction. So we'll do a ratio here. So CaCO3 to phosphoric acid is H3PO4. From the reaction, the ratio is 3 to 2. So if I have 0.25 that's been used, I can call that x. Let's cross multiply. So 2 times 0.25 is 0.5 equals 3 times x is 3x. That means x is equal to 0.17. So this is going to be 0.17 moles of H3PO4. Now they are asking for the volume. So if we know the number of moles and we know the concentration, because they've given us the concentration here, we can calculate the volume. So concentration is equal to number of moles divided by volume. 1.25 is equal to 0.17 divided by V. We can then solve for V. V is going to equal 0.136 moles dot dm to the power, actually not moles per dm cubed, it's going to be V is equal to 0.136 dm cubed. Moving on now to question 8.4. Calculate the percentage yield of carbon dioxide if 4 dm cubed of CO2 was formed at STP. So let's figure out what you're supposed to form. So we'll do the ratio of CaCO3 to CO2. Now from the reaction, the ratio is 3 to 3. So if you have 0.25 here, then this is going to be 0.25 here. So we can then calculate the volume at STP. So the volume of CO2 is going to equal the number of moles times Vm. So number of moles is 0.25, Vm is 22.4, and that's equal to 5.6 dm cubed that should have formed. So we call this the theoretical. So to calculate the percentage yield, you take the actual amount that you got divided by the theoretical and you multiply by 100. So they actually got 4. They were supposed to get 5.6 multiplied by 100, and that's equal to 71.43%. That's the whole paper, guys. If you stuck around till the end, please leave a like, share, and subscribe for more. And I'll see you in the next one. Bye-bye.